California's water infrastructure is a massive investment, but it's under constant threat from within. Did you know overgrown aquatic weeds can make a waterway lose up to 370% more water to the air? This staggering water loss is just the start of a much larger, more expensive infrastructure problem. It's about choked pipes, blocked canals, and compromised water delivery systems failing statewide. We'll show you why the conventional approach fails and how a direct physical solution offers a cascade of benefits. Invasive vegetation is a physical barrier. It clogs pipes, pump intakes, and control gates, causing operational failure. A direct problem demands a direct solution: physical removal. Mechanical harvesters cut and collect this biomass. This isn't a chemical treatment. There's no delay. The water is usable for recreation and irrigation immediately. So, the flow is restored. Problem solved, right? Not if you leave the dead vegetation behind. What happens next is the real issue. Chemicals kill the plants, but the biomass sinks. This decaying matter becomes fuel for a destructive ecological cycle. Over time, this organic decay builds up as muck and sediment, reducing reservoir capacity and smothering habitats. So how does this decay poison the water? It's a destructive cycle, and in a moment, you'll see exactly how it works. First, decomposing plants release massive amounts of stored nutrients like phosphorus and nitrogen back into the water. These nutrients then act as fertilizer for the next wave of invasive weeds and harmful algae blooms. The decomposition process itself consumes huge amounts of dissolved oxygen, creating dead zones that suffocate fish. The chemical approach creates a feedback loop: kill weeds, release nutrients, fuel more weeds, and repeat. You treat the symptom, not the cause. Mechanical harvesting breaks this cycle completely. By physically removing the biomass, you remove the nutrients from the system for good. This ecological restoration has direct benefits. It improves fishery health by creating strategic channels for predator fish. It also has surprising public health implications. Dense mats of aquatic weeds are ideal breeding grounds for mosquitoes. Removing these weed mats is a form of integrated pest management, protecting communities from vector-borne diseases. So it's better for infrastructure and ecology. But what about the bottom line and regulatory compliance? A common misconception is that mechanical harvesting is more expensive. The long-term economics tell a different story. You eliminate recurring herbicide costs, you avoid expensive infrastructure damage, and you stop that massive water loss. Repeated chemical use also leads to herbicide-resistant weeds, forcing the use of stronger, more expensive chemicals. Physical removal helps managers meet California's increasingly strict water quality standards with a compliant, predictable strategy. We've seen it's better for infrastructure, ecology, and economics. But what if this problem could become a valuable asset? Remember all that biomass we removed to break the nutrient cycle? That material isn't waste, it's a resource. Harvested aquatic vegetation can be repurposed into valuable compost and soil conditioner, or even used to generate biogas. Let's return to where we started. Choked waterways. That decomposing matter doesn't just hurt fish, it releases greenhouse gases. By removing the biomass before it rots in our reservoirs, this method reduces a source of climate-warming emissions. The conclusion is clear. We must stop thinking of this as just weed control. Mechanical harvesting is an integrated strategy for infrastructure resilience, ecological restoration, and economic innovation. It provides immediate results without chemical residues, without water use restrictions, and without fueling a cycle of future problems. Companies like DK Aquatic Inc. provide the specialized equipment and statewide capability to implement this strategy effectively. For California's water managers, the choice is about securing a sustainable, compliant, and resilient future for our most vital resource.